So let's look at extending our factoring of trinomials now. Instead of x squared plus bx plus c, we're now going to factor ax squared plus bx plus c, where a is not 1. Let's take a look. Well, we're still factoring trinomials, except what we're doing now is what happens if this is not a 1 there. So we're factoring ax squared plus bx plus c, something x squared plus something x plus something. So let's try a couple. Factor what are these again? These are polynomials, and they have the highest power of x is 2, all right? So these are polynomials degree 2, and there are 3 terms. So the most specific we can be is that these are trinomials. And as before, we're going to factor these and get 2 binomials. But the process is a little different this time, and it's a little harder. So let's have a look at it. First one, we're going to factor 3x squared plus 8x plus 4. And as I said, we're going to get 2 binomials. Something times something equaling this. But this time we have a number here that's not a 1. So that method we did before, when we've got to find the 2 numbers that add to give 8 and multiply to give 4, that's not going to work this time. We're going to do something a little bit more complicated. And now this might be different from the textbook, okay? So if it is, you can look at my way, you can look at the textbook's way. I think there are even other ways out there. You might find something on YouTube that you like. As long as you can get the right answer, I'm happy, okay? But this is how I do it. I've done it a lot of different ways. I've seen them all, and I always come back to this. I think it's the quickest way to do it. What we do is, we look at the factors of this number here, okay, that term, 3x squared, and we look at what are the factors. We think it's something times something, so 3x times x equals 3x squared. So this times this must equal this. And then over here we put the factors of this number. All right, so what are the factors of 4? Let's try 4 and 1. And what we do is we cross multiply. We do this times this, which gives us 3x, and then we do this times this, which gives us 4x. We then want that sum to be equal to this term, 8x. Is that possible? Can 3x plus 4x ever give 8x? No. Okay, so we're going to try something else. All right, instead of 4 and 1, let's try 1 and 4, and we do it again. 3x times 4 is 12x. X times 1 is x. Can that ever give 8x by summing them up? No, it can't. All right, what else can we do? All right, we're going to try another combination here. 2 and 2. Okay, because 2 times 2 gives 4. Well, let's give this a try. 3x times 2 is 6x. 2 times x is 2x. Can that total to give 8x? Yes, it can, okay, that works, okay, and that is actually the answer. All right, we now look at that. 3x plus 2, that's one of your factors, 3x plus 2, and your other factor is x plus 2. Again, the order doesn't matter. This could be x plus 2 here and 3x plus 2 here. The order does not matter because of the commutative property. Okay, and that is the answer. If you did FOIL on this and collected the like terms, you would end up with that. So that is how you factor trinomials where the leading coefficient is not 1. Okay, let's try another one. So B, 2x squared minus 13x plus 6. Again, we're going to do the same process. So our leading coefficient is not a 1. Let's do our cross method here. I erased the working here because I need the board space. You should not erase, okay? We like to see you working. So, factors of 2x squared. 2 is prime, so we've only got 2 and 1. It can get a little bit harder later on. And what about the factors of 6? Okay, 3 and 2. Let's do it. So remember, factors of 2x squared go here and here. The factors of 6 go here and here. 3 and 2. And what we want is the sum of the products of these cross products here to add to give this middle number here. So 2x times 2 gives 4x. X times 3, 3x. And this time we've got a negative, so the negatives also come into play. The negatives have to work as well. Negative 13x. Can 4x plus 3x ever give negative 13x even if you play with the minuses? No, it can't. Okay, so we're going to try something else. What else can we do? 3 and 2. Let's try 2 and 3. 2 and 3. Do it again. 2x times 3 is 6x. 2 times x is 2x. Can those two, even if you play with the minuses, can that sum ever be negative 13x? No, it's impossible. Alright, so this is it. It's trial and error. You just got to keep going until you find the combination. Alright, what other factors of 6 do we have? No. 1 and 6. This should be it. 2x times 1 gives 2x. 6 times x gives 6x. Can these, even if you play with the signs, ever give a sum of negative 13x? No, it doesn't work. Maybe this one can't be factored. Have I tried everything? One more combination. Let's just reverse the 6 and the 1. Put a 1 here and a 6 here. Hopefully we're getting there soon. All right, I'm just going to erase some working here just because I need the space. You should not erase your working. 2x times 6 is 12x. 1 times x is 1x. Can these ever be added to give negative 13x? Yes, that will work if this and this are both negatives. So let's backtrack here into our cross product thingy, mabob, and work the minuses in as well. If I want a negative 12x, then that means this has to be negative. If I want a minus 1x, that means this has to be negative. And final check, this times this equals this? Yes. Minus 6 times minus 1 equals plus 6? Yes. Okay, we got it. So this factors to 2x minus 1 and x minus 6. Okay, and that, ladies and gentlemen, is how I do these. And I think this is the best way. So again, if you did FOIL on that and collected the like terms, you'll end up with this stuff here. And this could also be the other order, okay? You could have the x minus 6 here and the 2x minus 1 here. So that is how you factor these trinomials where the leading coefficient is not 1. Let's try a couple more. So 2 more of these types, C and D. Now I've got to confess, I was kind of doing it as a setup last time when I did A and B. I was intentionally going the wrong way, okay, and getting those wrong numbers, and I got the right number at the end, okay, because I just wanted to show you the process. This time, sometimes you get lucky and you get it straight away. So let's try this one. 3x squared minus 5x minus 2. So I'll still do my colors today. So I'm going to do our cross method here. You do our cross. And the factors of 3x squared are going to go here and here. So easy, 3x and x, because 3 is prime, so it's just 3 and 1. Factors of negative 2 are going to go on the right side. So 2 and 1. Start off with. And now let's try our cross product. So 3x times 1 gives 3x. X times 2 gives 2x. Looking good. Can these two add to give negative 5x? Negative 5x. Yes, no problem. Both are minus. We've got it. And let's backtrack here. So minus 3x is going to come from this times this. So we need a minus there. Minus 2x is going to come from this times this. And there we go. So done. But just before we rush into our final answer, double check. This times this should give this. Good. This times this should give this. Does that work? Minus 1 times minus 2. Does that give minus 2? No, it doesn't. This does not work, actually. Okay, because it failed that final check. So let's try something else. Instead of 2 and 1, let's try 1 and 2. So you can never be sure until the very end. Let's try it again. 3x times 2 is 6x. X times 1 is x. Can these two add to give negative 5x? Yes, they can. I need a negative 6x and a plus 1x. Let's backtrack and put these in. So the negative 6x is going to come from this times this. We need a minus there. We need a plus 1x, so that's going to be a plus. Final check. That times that gives that. Yes. That times that gives that. Now it works, okay? And we'll get our minus 5x there. So to factor that, the answer is 3x plus 1 is one binomial, and the other binomial is x minus 2. And that is C factored. Okay, let's try one more. So I've just erased my work in there, which you won't be doing. So another one, another trinomial we're going to factor into a binomial. Let's do it. Here we go. So this time, you'll notice we don't have a prime number here. We've got 4n squared, and we're using n instead of x. No problem. What are the factors of 4n squared? Oh, wait a second. This is not as easy either. So you can do 2 and 2 and 1 and 4. So sometimes this might not be right. You've got to change this one now, which kind of makes more combinations. It might take a little bit more time. All right, let's try 2n and 2n. What about over here? 3, so, yep, 3 and 1. So the factors of 3 are going to go here. 3 and 1. We worry about the plus and minus later. And cross multiply, so 2n times 1 is 2n. 3 times 2n is 6n. And we want this sum to equal that number there. Can that give plus 11n if we fool around with these pluses here or minuses here? No, it can't. So we're going to try something else. 1 and 3. Here we go. 2n times 3 is 6n. 1 times 2n is 2n. Can that give 11n? No. Well, it's actually the same, isn't it? Does not work. So what else can we do here? Well, instead of 2n and 2n, we're going to have to change this side this time. So let's change it to 4n and 1n. Now let's give it a try. 4n times 3 gives 12n. n times 1 is n. Can that give a sum of plus 11n? If we play around with the pluses and minus. Yes, it can. So what do we need? We need a plus 12n minus 1n. Now that works. Let's backtrack here. We want a positive 12n. So this gives the 12n. That's going to be positive. We want a minus 1n. This gives the 1n. So that's going to be minus there. And there we have it. Final check. That times that gives that. Yes. That times that gives that. Yes. We got it. 4n minus 1 times n plus 3. And the order can be reversed. It doesn't matter, okay? And there we have it for D. Pretty tricky stuff, right? And example 2. This is a little bit different to example 1. How? Can you see how this is different? Are we factoring a trinomial? No, we're not. We are solving. So when we say solve, it's different. We're looking for x equals something and x equals something as the answer. Solve this is an equation. I guess you could say it's a polynomial equation, right? But it's not an expression, is it? Okay, it's an equation. And it's the same as when we did it with 9.5a, right? It's going to still equal 0, and we're just going to factor the left side, and we're going to use that zero product property, okay? We get something times something equaling 0. Something times something equaling 0. And our solution is going to be this can be 0 or this can be 0. Okay, but our factoring is going to be using this cross method because our leading coefficient is not 1. Let's do it. I've got some work to do down here. I might come over and try and squeeze it in here. So here we go. I'll do my colours again. Factors of 3x squared are going to go up here on the left. 3 is prime. Okay, makes less combinations, a little bit easier. And our factors of negative 10 over here. We won't worry about the minuses just yet, but 1 and 10. See if that works. And we want the sum of the cross products to equal negative 13x. So let's try it. 3x times 10, 30x. Obviously this is not going to work. Okay, 1 times x is x. So after a while you'll start seeing that some combinations can't work without actually going through the process of doing it. Minus 13x, no way, Jose, that's not going to happen. And if I switch that, I'm going to get, can you actually do it in your head? I'm going to get 10 here and 1 here. So I'm going to get 10x and 3x. Well, that might be it. That is worth doing. So let's put the 10 here and 1. Multiplying that out. 3x times 1 is 3x. X times 10 is 10x. Can that give a total of negative 13x? Yes, it can. We need both minuses. And let's put that back up into here. To get a minus 3x, this must be minus. To get a minus 10x, this must be minus. Final check. Does this times this equal this? Yes. Does this times this equal this? No, it doesn't work. Minus 1 times minus 10 is not minus 10, it's plus 10. So this doesn't work either. What else can we try? 5 and 2. 5 and 2. If I did that, I'm going to get a 5x and a 6x. 6x and 5x, is that going to work? Can that give a 13? No. So after a while you can skip a few steps here. What about this? 15 and 2. Yes, I think this is it. 3x times 5 is 15x. X times 2 is 2x. Can this give negative 13x if we play with the signs? Yes. And then a minus 15x and a plus 2x. So I've got a minus 15x, which means this has to be minus. And I've got a plus 2x, which means this has to be a plus. We get that, and we get that. 3x plus 2 and x minus 5. I erased the working because I need the board space. So if we continue this, this could be 0 or this could be 0. So I'm not going to do this. I want you to tell me what the answers are. X equals what or x equals what? That's going to give us two solutions or two roots. What are they? Put your answers in the comments. Factor the trinomial, but the problem is this time, this minus here. What do we do when there's a minus there? This is what we do. Minuses are kind of annoying. We don't like them. So what I'm going to do to start with is take out something that's common to everything, all right? But there is no common factor here. There is no greatest common monomial factor. That is true, but what I want to do is get rid of that minus. I'm going to take out minus 1. So then I'm going to be left with a nice trinomial here with no minus sticking out the front. Okay, so let's think backwards. Minus 1 times what gives this? 3x squared. Minus 1 times what gives this? Minus 13x. Minus 1 times what gives minus 4? That will be plus 4. Agree? So this times this gives this. This times this gives this. This times this gives this. Looks good. So what we're going to do now is that minus 1 is just going to copy down the next few steps. Other than that, we're going to ignore it. Okay, so let's just factor what's inside the brackets here. And ignore the minus. That's just going to end up at the end. But in terms of factoring now, we don't have to think about the minus. Our next step is going to be minus 1, binomial, binomial like that. So let's do it. We want factors of 3x squared on the left, 3x, x. 3 is prime, lucky. Let's put factors of 4 over here. 2, is this going to work? 3x times 2 is 6x. So we've got 6x and 2x. Can that give 13? No. So hopefully you're getting better at this and you don't have to write out every step. What about 4? So 4 and 1, let's try that. So this gives us 12x and 1x. Can that give us negative 13x? Yes, it can. I think we got it. 3x times 4 is 12x. 1 times x is x. We want that sum to equal negative 13x. For that to happen, we need both minuses. Let's go back. Minus 12x, so that means we're going to have a minus here. Minus 1x, so that means we want a minus here. Final check, don't forget this final check. Does this times this equal this? Yes, it does. Does this times this equal this? Minus 4 times minus 1 equal plus 4? Yes, it does. We've got it. So this factors to 3x minus 1 and x minus 4. And that is the final answer. Okay, and actually you don't really need to say minus 1 at the front. You could just leave it as a minus like that. And that is fine. Remember, the order can be different, okay, but this is what I'm looking for, this answer here. Okay, so that's how we handle trinomials where we've got a negative leading coefficient, okay? Take out the minus 1 and then just do it like normal. Let's try one more. Example 2, we're going to solve an equation as our last example. So 5y squared plus 3y equals 14. We're going to solve. So this is not a factor question, this is a solve question. So our final answer is going to look like y equals, we're going to get 2 values for y. So when the question says factor, we end up with an expression with brackets. But when the question says solve, we end up with x equals something or y equals something, something like that. So this is a solve question. We're finding the zeros or the roots or the solutions to the equation. How do we do this? Remember, all our solving in this chapter has been based on the zero product property. Something times something equals 0. We don't have 0 here. That's what we're going to get first. So we're going to take this 14 over. Get it equal to 0 on one side. 5y squared plus 3y minus 14 equals 0. Now we have a trinomial that we can factor. Let's factor that. Something times something equals 0. And we're going to use our cross method, okay? So we've got cross method. Factors of 5y squared are going to go up here on the left. 5y, y. Factors of 14 are going to go on the left side. And you know what? I'm not going to do this. I want you to do it and put your answers as a comment, okay? See if you all agree and get a discussion going if you don't.